high level concepts, again, you're probably, again, if you're out the gate, these are not the first things you're going to see, but there are words and concepts, and this is where sort of the difference in the boundaries, and this is what I want to, I guess the takeaway from this one is understanding there is a boundary between business intelligence and GIS, and there's a point where there's a lot you can do as you incorporate maps, and then there'll be levels to things that you may want to engage your GIS colleagues to help, or there's parts of the project that you just may pass along to them that are just definitely outside of scope. But there's concepts, for example, like a heat map will show raw density where things are. And then there's hotspots, the GETUS org GI show statistical significance. Is this cluster actually meaningful or just random noise? So regional averages can hide local variation. So the spatial autocorrelation reality, things that are close together behave more similarly than things that are far apart. So that's why regional averages can hide local variations. There's like Tobler's first rule of geography, that things that are closer together are more related than things that are far apart. And so that's kind of just kind of keeping to thinking about sort of just some of these ideas of when you look at location data, to actually ask questions like, actually, does this make sense? And so sort of inside the engine of the hotspot analysis is statistical significance. And so just basically embracing statistics, I think we do as data science professionals, but it really applies to anything that's location based. So the Find Hotspots tools will evaluate a local neighbor's average against the global data set to find non-random clusterings, things that are actually significant, things that will help you tell a story that makes sense. And then you get to sort of do spatial joins. The where based is the VLOOKUP. So connecting data by location, not by ID. So you can join customer points to demographic polygons simply because the point falls within the ingest raw parquet data. So you're looking at sort of that ST_within or ST_intersects. So you can clean out out of bounds anomalies. So kind of get rid of like kind of the null, the execute ST within with a demographic polygon, and write enriched data tables to one link. So this is kind of how you are joining your data, and you're joining it based on the location.